Hello everyone. Today we are going to look at zeros of polynomial functions. So what is a real zero of a polynomial function? A real zero of a polynomial function is defined as if I have a polynomial function, say f, and a is a real number, the following statements are equivalent. X equals a is called the zero of the function f. Or we can say that x equals a is a solution of the polynomial equation fx equals 0. Or x minus a is a factor of this polynomial f of x. And the last one, the point a, comma 0 is an x-intercept of the graph of this function f. So all these four statements basically are meaning the same thing. And in a very simple thing, suppose you have a function. Let me draw a graph. So if I have a function like this. So here, there are three zeros of the function. The first zero is this. The second is this. And the third is this. Suppose I name this as A1, A2, A3. So x equals A1. So what are the zeros of this function? Remember, you can have more than one zeros, okay? So zeros of the function, so zeros of fx are x equals a1, x equals a2, and x equals a3. Or we can look them as, so this is the point, we will say this is the point a1 and 0, this is the point a2 and 0, and this is the point a3 and 0. So these are the three x-intercepts of the graph of this function fx. Or x minus a1, we can say this one as also, that x minus a1 is a factor of the polynomial, is a factor of this function fx. So let's, so this is the function fx I'm talking. Or x minus a2 is a factor of fx, or x minus a3 is a factor of fx. So it's different ways of saying the same story. Now let's go ahead and do some examples here. Now the first question is, find all the zeros of the function fx, and this fx is a cubic function which is given by x cubed minus x squared minus 2x. Now to find real zeros, in other words, I want to find zeros. That means we equate the function fx equal to 0. Now replace this function fx by the cubic function on the right hand side. X cubed minus x squared minus 2x equal to 0. To find answers, remember the zero factor property. In other words, can we write this expression as a product of some expressions? Now notice, in order to do that, x is common. So we take the x out. What do we get? X squared minus x minus 2. Now this is a nice little quadratic function and we all know how to do it. So we can write this as x times x minus 2, x plus 1 equals 0. So now here we apply the zero factor property, remember. So that tells us the zeros of the function are either x is 0, or x is 2, or x is 1. So what are the corresponding x-intercepts, guys? The corresponding x-intercepts are 0 and 0, 2 and 0, 1 and 0. Oh, minus 1, guys, I forgot. This is minus 1. Okay, minus 1. Remember, x plus 1? Remember, it's x plus 1 equals 0. So x is minus 1. So minus 1. So what are the factors of the polynomial? These are the factors. Just pick them up, write them. X. Remember, x is the same as x minus 0. So these are the way we write the factors. So factors are x minus 0, which is the same thing as writing x, or x minus 2, basically picking up the factors we had made earlier. And the third one would be x minus of minus 1, which is x plus 1. So 3 factors are x, x minus 2, and x plus 1 are the factors. Let's look at another example. Yes. So this example again is a cubic function, which is given as x cubed minus 6x squared plus 9x. So what are we going to do? Here x is again fx is equal to 0. And we write x cubed minus 6x squared plus 9x equals 0. Take the x out and we get a nice quadratic function in between, and which we can write this as x times x minus 3, x minus 3. It's a perfect square, guys, this thing. Now, so what are the zeros? Applying again the zero factor property. Remember, it's a zero factor property, guys, we are doing. We get the zeros are x equal to 0, 3 with multiplicity 2. Okay, guys, you got to be careful here. What does the zero factor property says? X is 0, x is 3, x is 3. So the convention in mathematics, guys, the convention is we do not repeat 3 and 3. If it is the 0 is repeated, we simply say 3 with multiplicity 2. That's how we represent these 3, which are the 2 solutions, and we write this as 3 with multiplicity 2. So what are the corresponding x-intercepts? So the x-intercepts are what? 0 and 0, 3 and 0, and we'll have to write it down 3 and 0. Yeah, but it's like repeating the same thing. What are the factors of the polynomial? The factors of the polynomial are x minus 0, x minus 3, x minus 3. But when we talk about the zeros, we write it in this form. X equals 3 with multiplicity 2. Now let's look at a higher degree polynomial. So here we're going to look at a polynomial of degree 4 and find the real zeros of this function. So this 4th degree polynomial is given by x4 minus x cubed minus 20x squared. We're looking at real zeros. So real zeros means what, guys? We are basically going to put fx equal to 0. That means the right hand side is going to be equated to 0. And now we try to write it as some factors. When you look at individually to each of this expression in this on the left hand side, we see x squared is common. We take the x squared out, we have x squared minus x minus 20. Once again, what do we see? A nice little quadratic function. And we can write that as a factors of x minus 5 and x plus 4. And I forgot that, guys, there is this little x square here. Okay, so the zeros of this function are x equal to 0. Now remember, there are 2 times x goes here. So we write x equal to 0 with multiplicity 2. 5 and 4. Remember, it's a 4th degree polynomial. You will have 4 zeros, and we'll talk about that later again in one of the videos. So let's write down what are the corresponding x-intercepts. 0 and 0, 0 and 0 is basically repeated because of x squared, and then 5 and 0, and 4 and again minus 4, it should be there. Nice little typos we are having, guys. It's a minus 4. So minus 4 and 0. So what are the factors of this polynomial? Basically this. So it's going to be x. X is basically the same as x minus 0. We can just simply write that. I can want to repeat it, x again, and then x minus 5 and x plus 4. That's what we have. Remember, x plus 4 is y. It's x minus of minus 4. And that's what it is equal to. Now, we are going to look at a problem from a different angle. We will be given zeros, and we will be asked to write a polynomial function. Okay. So the first thing we're given is, we say find a polynomial function which has the given zeros and give us the degree, as well as the zeros have multiplicities. So when you have given the zero as 3, minus 4, and 0, that means it's not giving us any multiplicities. We'll let it be. So that means there are only 3 zeros of this function. So how do we write it down? The factors are written as x minus 0, so it's minus 3, and I just wrote it over here wrong. So it's going to be minus 3, guys. Many typos are coming, and it's a positive 4. Sorry. So it's x minus 4 and x minus of minus 3. So when we do the math here, it's x times x minus 4, x plus 3. Then when you open up this, do the multiplication between these two expressions, you get x squared minus 4x plus 3x minus 12. And then you multiply this by x outside. So you, first of all, get the like terms together. So x times x squared minus x minus 12. And then distribute the x inside, x cubed minus x squared minus 12x. So that's a polynomial function. And what is the degree of this polynomial function? The highest power is 3. Okay. Now let's go ahead and look at another example where we will see a multiplicity here. So here we're looking at a polynomial function with the given zeros. Zeros are 6, minus 5, 4 with multiplicity 2. That means this is repeated twice. And we like to write down this polynomial function and write down the degrees. So the first thing is, write down the function as x minus 6, x minus of minus 5, because minus 5 is this. So that's how you write it down. The factors are written as x minus of whatever the 0 is. And multiplicity 2 means x minus 4, x minus 4. So when we open this up, what you get? X minus 6 times x plus 5. That's what we're getting. X minus 4, x minus 4 just basically comes down. Now I'm going to do the multiplication of these first two expressions and the last two expressions. The last two are here, the first two comes here. When you multiply the first two, what do you get? X squared minus 6x plus 5x minus 30. And getting the like terms, we get x squared minus x minus 30. Okay, now let's look at this one. X minus 4 times x minus 4. We see x squared minus 4x plus 16. And then we add the like terms and we get x squared minus 8x plus 16. Now, we are going to multiply these trinomials. Trinomials is an expression with 3 terms. So there are 2 trinomials. What are we going to do is we're going to fix one of them and basically distribute the other. So I'm going to fix x squared minus 8x plus 16 and distribute the terms. So x squared multiplies to x squared minus 8x plus 16. Then we have minus x, and then I'm going to multiply it with x squared minus 8x plus 16. Then minus 30 times x squared minus 8x plus 16. Now after that, what are we going to do? Just distribute inside. So the first expression, we're going to get x4 minus 8x cubed plus 16x squared. Now let's look at the second expression here. And now we're going to distribute negative x inside x squared minus 8x plus 16. What do we get? Minus x cubed plus 8x squared minus 16x. Let's look at the very last expression, which has a negative 30 in the front. And we're going to distribute negative 30 to x squared minus 8x plus 16. What do we see? Minus 30x squared. There's a duh. So 30 times 8 and 30 times 16, guys. Oh, a mistake. So we will have to, I will just quickly change the numbers here. So it is 30 times 8. What is 30 times 8? So you're going to have this 240. So let's remove this. So this is going to be plus 240x. Okay. And then minus 16. Minus is right, but 30 times 16. What is 30 times 16? 480. So it's minus 480. Okay, now let's add up the like terms. So x4, 8x cubed and another x cubed minus 9x cubed, a 16x squared and an 8x squared, that means 24x squared minus 30x squared. That is going to give us 24 minus 30, minus 6. And then we look for x. So now 240 minus 16. So what are we going to get with 240 minus 16? 224. So these two terms will be changed now. It will be plus 224x minus 480. Okay, let's look at the polynomial function. Now the polynomial function is x4 minus 9x cubed minus 6x squared plus 224x minus 480. And what is its degree? The degree highest is 4. Let me correct this one down. Plus 224x minus 480. Okay, let's sketch. Now, let's look at another example. We would like to sketch the graph of a function x cubed minus 9x. Now, to do this one, guys, remember the first thing we have to look at. When we are sketching, we would like to know the leading coefficient. The leading coefficient helps us where the graph is rising and falling. To do the leading coefficient, what is the degree? The degree here is 3, which is an odd. Okay, that means it will rise and fall. Then what else also we see? That not only it rises and falls, then we would also have, what is the coefficient? The coefficient of this function is 1 greater than 0. So when it is greater than 0, what does that mean? So it's a cubic, that means it's going to rise to the right and fall to the left. That's what it means. So the leading coefficient says if your degree is odd and the coefficient is positive, the graph rises to right, and that's what we have, and falls to left. This is what we have. Now, what are the zeros of the polynomial function? Because that will tell us the graph where it is going to cross the x-axis. So let's do that. So we have x cubed minus 9x to be 0. X is common. We have x squared minus 9 to be 0. Remember the zero factor property we're going to apply. That means x is 0 or x squared minus 9 is 0. What does that mean? X squared is 9, x is plus minus 3. So what are the x-intercepts? 0 and 0, minus 3 and 0, and 3 and 0. So moving forward with this one, what are the points the graph is going to cross? This is one of the points. The other point is a 3, and the other point is a minus 3. Now, when this happens, we know because after minus 3, it has to go down. That's what the graph says. Above positive 3, it has to go up. Now we have to see how do we fill up the terms in between. Okay? Okay. Let's come here. Now, the graph is like this, guys, at this point. We have minus 3, and we know because it's an odd degree with a positive coefficient for x cubed, that means the graph goes down on the left, and from 3 it goes up because that's where it is going to cross. But there are 3 points where the graph is going to go. So we like to know, we know it's going to go up and down. But the thing is, we like to know what are the values in between minus 3 and 0 and 0 and 3. Okay, so what do we do on this one? We just plot some sufficient points to get an idea. We already have a calculator which is going to give us the thing, but it's nice to plug in some values. So x and fx is x cubed minus 9x. Now remember the points we already know, -3, 0, and 0. So I would say -3, a 0. These are the points I know. So I want to fill up the points in here. -3, 2, because which we already know is going up and down. Even if just to make sure, that we are on the right track, we can say -4, we say -2. Make your life simpler, guys. I would go for an easy number 1, -1, 1, and a 4. So when you plug it over here, so that means f of -4. What does that mean? -4 cubed, -9, and -4. What do we see? The answer is -28. That means the value's down. So remember, -4 comes here. So that means we're right. Okay. Now -1. When you plug in -1, what do we get? We get an 8. You can do the math. When you plug in a positive 1, you get -8. Plug in a positive 4, we get 28. So clearly, -3 and 1 numbers are positive. So that means the graph will go, even if you put in your calculators, like this, and from 0 to 3 like this. So here is the graph of our function. Thank you.